Is that what you're saying?
Sure, I'm a lab person. I can project, I think. Yeah, so thanks to Cast for the invitation to talk. Altiscale is actually located about 2 blocks in that direction, so the Cast people and Altiscale people often kind of meet in the middle of the Nut House over here on California Avenue after our weekly demo meetings or whatever. So this talk tends to resonate pretty well with groups of people who are data scientists or people who support data scientists. So I think John asked earlier, how many software engineers in the audience today? Okay, so mostly software engineers. How many data scientists? People who manage data scientists or engineering teams, and then other folks? Okay, so this is really going to be kind of a birds of a feather session then, because as you'll see, we at Altiscale are infrastructure nerds, and a lot of what we do is in support of data scientists. So I imagine that a lot of, if you're in this audience, a lot of what you're doing is in support of data science or actually something that falls under data science itself. So I'll talk about who we are so that you can understand our perspective, talk a little bit about the problem that we've created over the last 10 years or so, and then go through some tips about how to create a really enjoyable and productive kind of environment for data scientists to use. And I'll try to go quickly, so I may not have a whole lot of time to talk about our experiences. Our CPO is Rami Stata. Rami was really the executive sponsor for Hadoop over its lifetime at Yahoo. So it's shortly after Rami started at Yahoo, he invited Doug Cutting, who is the founder of the Hadoop project, to join Yahoo, and Doug reported to Rami for a while. And then just as Rami was leaving the company, he was working with closely with Jay Rossiter on spinning Hortonworks. Jay and, of course, Eric Fortines to spin Hortonworks out of Yahoo. So his experience was really bracketed in terms of making the investment in Hadoop and maturing it to the point where it could really fly on its own. So the other notable person to mention at Altiscale is Hadoop Wimmer, who is doing the operations for up to about 40,000 nodes of Hadoop at Yahoo. So we kind of got together, and what we do is we operate Hadoop and the whole Hadoop ecosystem for other companies. And of course, it's not just Yahoo's, it's people from Google and Netflix and LinkedIn and other web scale companies. So again, our perspective is we've been providing these systems to data scientists for a while, and we have some observations that tend to resonate with data scientists about the kind of environment that they need to be productive based on what do data scientists do. Word about myself, everything I know I learned from advertising. So when I joined Yahoo, Hadoop was just ready to emerge from the algorithmic web search group into the rest of the company as a whole. We first took it through search advertising and then display advertising and then added to the content products. So I was very much kind of on the receiving side of the infrastructure and making sure that it was appropriate and invested in such a way that we could use it to actually make money off of the platform. So at that time, my favorite data scientists were really awesome because they said, sure, Java, we'll code in Java, because MapReduce and Hadoop was kind of the only game in town for processing large data sets. It was kind of eye-opening in 2006, 2007 to be sitting at a table where someone would say, yeah, my data set's fairly small, it's only a couple hundred terabytes. So that was kind of an awakening, and for people with data that size and larger, Hadoop was really the only game in town, except for our friends at Google, of course, where they invented a lot of the technology. So it was great that data scientists at the time were willing to code in Java and do whatever they needed to get things done. But roll forward to today, my favorite data scientists today say, I don't know Java, I don't want to have to know Java. I know enough SQL to get by, but really I know R or Python or one of the more modern data analysis languages and one of the higher level languages, or Scala for that matter, that people are using to do analysis. So the problem that we kind of created in the Hadoop ecosystem, at least to date, is there's kind of this back and forth between people who are okay or really adept at Java programming and can really make efficient use of the platforms, and data scientists, kind of the broad majority of data scientists these days, who really need higher level tools that are focused on statistical analysis as opposed to just the kind of plumbing of getting data from point A to point B. So given this problem, the question is, well, how do you create an environment that's really productive and a pleasure to use for the majority of data scientists these days? And I've got 5 tips here, and I'll run through them quickly. I'll spend most of the time on Know Your Workflow because it kind of, especially for an audience like this, it kind of explains what data scientists are doing. And we've worked with some of our customers to kind of extract this view. So when I talk to data scientists, what I say is data scientists tend to be focused on the core part of the problem that they're working on, which tends to be modeling, finding the signal in the noise of large data. But what we really advocate to the data scientists is that they understand the end-to-end workflow that I'm about to present so that they can have a productive conversation with us infrastructure nerds. So here's the Hadoop workflow, and although simple, this seems to resonate with a lot of different teams and companies that I've talked to. The caveat going into this is every organization is different, but like I said, there is quite a bit of resonance. So this is kind of end-to-end the data scientist workflow from the sources of the data all the way out to serving. And I'll go through each of these steps, not quite in sequence, but kind of in the order that people think about. So you start with source data. We've heard a lot about source data, especially FluentD tonight. And weblogs, of course, were the first example of really large data sets that were commonly processed in Hadoop. Anybody nerdly enough to recognize that kind of, which of our many web servers generated that one? John's nodding his head.
I'm not. I've seen Mozilla all over that.
Oh.
Right. And then you have Apple WebKit as well, and Safari. So this is like a,
yeah.
It looks like a weblog.
Yeah, so it's totally a weblog. Anybody know what generates this specific format? So this is Nginx.
Nginx.
Yeah, so I see some heads nodding, but the next point was a good one, which is, hey, look in here. You see that this is an Apple WebKit browser, and it's coming from a certain version from which you can deduce that it's an iPhone 5 that's accessing the site. There's all kinds of good information here, but it's structured and messy. So for example, the date format is whatever the folks at Nginx deemed was a good date format. So the next step here tends to be taking that and getting it into a structured format, what we call production cleansing, and then into a structured data store. And we keep hearing about Hive tonight because Hive is a very common system to be using for your system of record structure store. And so I took the information from that weblog entry just now and said, okay, here's some columns that you might have where you've got the IP address, you've got the date and the time in normalized format here, and the rest of, and then maybe some normalization of the user information that may have come out of the cookies in the weblog into for user ID. So this process is very much a structuring and normalization process. But that's not what the data scientists are typically using directly. Where the data scientists tend to be living is what we call modeling, which is the statistical analysis systems that are trying to extract the signal, which is the business relevant information from the noise that are in these data sets. So they tend to look at an output that kind of looks like this, that has the statistical properties of the portion of the data set that they're looking at, and maybe some values that they're trying to predict. And this is typically all in service of providing information to downstream people, either to the customers of the company who may be using web services, or to internal business intelligence users, or whatever. One of our customers coined this term flattening for this process that's somewhere in between the structured data store, which is typically accessed via SQL, and the modeling, which is typically done with statistical tools like R, or more for big data, Spark or H2O or whatever. Flattening takes this normalized structured data store and essentially turns that information into matrices that are appropriate for the statistical analysis tools. So for example, things that can happen here are building classifiers or other information that's going to be fed as matrices over here. So instead of having the structure that was directly derived from the web logs, we might have some characterization of the users who are accessing the system, which may be as simple as the number of times they visited, or maybe, say, a classifier of, say, how much of a nerd this person is. Okay, and then this is actually a bit more of a controversial part of the workflow, but something that's very important. If you think about the time frames that data scientists are using their job, they spend a lot of time in modeling. You can think of that as kind of the inner loop, where they're running a model, they're tuning coefficients or whatever, but eventually that will run out of steam. So they'll go back to the structured data store and say, hey, maybe I can build a new classifier, maybe I can extract more information from here. But every once in a while, the data scientists may have an idea about, hey, we think that there's information in the source data. And because it can be kind of expensive to process that source data all the way into the structured data store, we haven't actually captured it yet, but it's sitting here. It's kind of like diamonds in the rough that are waiting to be mined here. So the idea is that the data scientists, and this is controversial, need to go back and access the source data every now and then so they can find those diamonds in the rough. Like they might have a hypothesis about the predilection of someone using a particular browser, which was in the web logs to buy something, right? So what they do need to go back and get access to the source data. The reason why that's a dangerous thing is because since this data is unclean, it may not yield reproducible results. It may actually produce metrics that are different from the metrics that you get in all of the downstream business processes. I don't know if any of you have had this experience before, but the data scientists can say, oh, we can get a 30% revenue increase if we get access to this kind of data. And the problem is they're making that assessment based on data that isn't clean, so it can be fairly noisy. So there's often quite a bit of barriers placed in terms of getting to that source data. There's also the possibility that it has PII, personal information, or other kinds of information that are kind of regulatory, dicey to access from a regulatory point of view. Anyway, so that's the end-to-end workflow that seems to resonate. And one of the things that we say is, hey, look for areas where the data scientists can't go. So I said why exploration is an area where sometimes data scientists are prohibited from going. But there's this flattening process, so the data scientists need to get access to at least the right parts of the structured data store directly so that they can do that extract. On the flip side, we do encourage data scientists to know at least SQL or Hive, at least at the level that's supported by Hive, to be able to extract data and understand it. Production cleansing is often done by a data engineering group that's responsible for making sure that this data is cleaned and delivered in a reliable fashion and so forth. And then finally, sometimes there's an impedance mismatch between the modeling that the data scientists are doing and the downstream systems that provide business intelligence to say, sales teams or actually go directly into the serving systems of the company. So the signs to look for when data scientists are getting frustrated or not productive is when they're waiting for other teams to get their jobs done. So they're saying, hey, we need access to this web browser information or the version of a phone that's getting access, and there's this team that has other priorities, so we can't get to it, but we know there's a diamond in the rough there. The handoffs of data to and from between data scientists and data engineers, or if there's some sort of production cleansing that needs to get done, the data scientists may need to explain what they're doing and what they need. Or if they're just sitting there on Google, trying to figure out how to get their job done, that's another sign to look for. So in order to address some of those things, there are a few more tips here. One is to use best-of-breed tools. And our observation, looking across all of our customers and looking at all the companies that we've come from, Yahoo and Google and Netflix and LinkedIn and so forth, is there is no single tool that's good for all of these different jobs. We're not coming here and saying, our system, Spark is going to take over the world, or that this framework's going to take over the world. We really do have the opinion that there are different tools that are good for different uses. Just to point out a few, so if you're looking through structured data stores, we've partnered up with a company called Elation. They take kind of this social approach to allowing data scientists to do their work. So data scientists can see each other's queries, and if they're interested in a table that's in this database, they can see, okay, who's been doing queries on that database, and what queries have they been doing? And they can go to that person and ask questions. And then the queries that they do go back into the system. So it really encourages, at least within a company, collaboration between people. Not just in terms of conversations, but actually building the documentation, the data dictionaries about what is all this stuff in here. For exploration, so there's some interesting products in this area. Teradata purchased Revolytics with their Loom product. Tamer is kind of data science buy-in for data scientists. They use machine learning to try to figure out what data do data scientists want to see. Trifacta is kind of cool because it will ingest a data set. This is what Trifacta's interface looks like, and provide kind of histograms that allow you to kind of drill down and roll up when you're looking at the columns of your database. So there's some good tools emerging in this area. Out here in this serving area, we see everything from people kind of doing roll it on your own in JavaScript and D3 to Tableau, which is now kind of the veteran and dominant in this area, to new companies like Arcadia that are actually serving data right out of Impala and being able to provide interactive systems that are fetching data dynamically from the Hadoop cluster. We hear, but like I said, modeling is the inner loop here. So there are a bunch of companies and frameworks there. We all hear a lot about Spark these days. We've been working with a company called H2O for a while. They kind of preceded Spark and then adapted to Spark. So H2O started with a bunch of libraries that are distributed multi-processing libraries that really work well for big data, and they integrated well with R and Python, which are languages of choice for data scientists. And more recently, they've kind of adapted their software to run on top of Spark. So when I have a bit longer time to talk, I give a demo of how all of these things are working together on an Altiscale cluster. Right, so another tip here to data scientists, and this kind of gets into a bit of a religious war about data science, is we do believe that it's a lot more efficient from a time perspective to actually analyze your data at scale rather than in aggregates. And then finally, our last tip for data scientists is that they really need a help desk. So when we say self-service, that data scientists should be able to go to the source data or should be able to go to the structured store or to any of these places, we don't mean that they should be on their own. So they shouldn't be sitting there on Stack Overflow figuring out why MapReduce exploded. They really do need to have experts like us infrastructure nerds around to help them answer questions, but our mindset has to be we're teaching them to get their job done so that after they see the pattern of a problem, they can understand how things are working and they don't get stuck on the same thing. Okay, so that's the tips that we have for data scientists. I did promise Vikram, where he did ask, he's one of the folks here at CAST, to talk about why we at Altiscale believe that buying Hadoop as a service is the right way to go. So there are a whole bunch of ways to go out, of course, and to buy Hadoop and the Hadoop ecosystem and Spark and so forth. One is to buy a distro and set it up on premises, in which case you wind up doing a lot of day in, day out work, getting the tools to work together, getting them to keep working together, making sure the thing stays up and running. It's kind of the same story if you're running Hadoop on infrastructure as a service. You know, look, if your metric is I need the cheapest way to access S3, then yeah, you should really be on Amazon because S3 is their object store and so forth. But if you really want a productive environment where the data scientists can use these best-of-breed tools and can focus on getting their job done and getting that workflow done and not worrying about, oh, I've got nodes out on my Hadoop cluster, or I need to expand the cluster, or this whole thing is getting way too expensive, then we really do advocate buying Hadoop as a service, getting it all bundled together so from day one you can log in and start getting your job done, as opposed to from day one figuring out, oh, what AWS instances do I need, or what kind of nodes should I be buying. Right, so what we found in general is that data scientists, because they're so much focused on their inner loop, they wind up focusing on that modeling environment, and then overall they're not as productive as they could be across that whole workflow. So our main advocacy to data scientists is you have to speak up for yourself and say the kinds of things that you need to be productive. And I guess the moral for us infrastructure nerds is that we really need to be there to listen and to try to remove barriers. And really, at the end of the day, what we're doing is we're removing barriers so that data scientists can find that business value in our company's data as fast as possible. And that should be driving, whatever the business metrics are, ultimately the profitability of our companies. Right. That's pretty much all I had. Questions, comments, thoughts? Yeah.
So if you could just go back to the Bestofbreed tools.
Yeah. Yeah, and of course that wasn't exhaustive, so if your favorite tool isn't on there,
So I want to take 20 seconds to kind of set some background to my question, and I have a technical question to ask.
Yeah, sure.
So I basically have this management consulting firm that focuses on cybersecurity.
Yeah,
And we kind of sit on the intersection of business and IT, where we kind of advise board of directors of, where do you spend money, how much money do you spend on security stuff, right?
Yeah.
And I want to kind of get a thought on something. So in the boardrooms, everything is kind of being driven by legal liability these days. And you kind of brought up this point about data scientists kind of, identifying, signal in this haystack of noise, right?
Yeah.
AOL had this thing a couple of years ago where they released what called a sanitized data set, and people could kind of figure out about, PII, all of that stuff, right?
Yeah.
Even stuff like, hey, if you identify a Tesla owner in a particular zip code, you can most likely figure out who that person is.
Yep. Well, except for if your zip code is Atherton, but sure.
So my question is this: for data scientists or the workflows that you're defining right now, are there any tools or any best practices that you are seeing that's kind of coming up in this field? Because what the lawyers are doing, the corporate counsel is saying, hey, encrypt everything, and there's no way to encrypt everything.
Well, keep going.
And the second piece of advice is that make sure that you have a scrambled, test dev environment and a separate production environment.
Yeah.
So, what advice do you have, or what tools can you suggest that would make sense at both levels?
Right. So, so it is a combination of these different tools for regulatory compliance and actual security. And all of this, I totally agree with you, is really important and fundamental to this industry, this big data industry that we're continuing to have the growth that we hope and expect it to have. So a lot of it comes down to defense in depth. So it does start with encryption, and a number of companies, including Altiscale, are moving towards having all of the data encrypted at least at rest. So if you're not using the cluster for a particular data set, that data set is sitting there encrypted. And even if someone pulls the disks out of the cluster, you're still good. On top of that, the earliest regulatory issues that I saw with respect to Hadoop actually happened at Yahoo. And I've got a long story about this. To make a long story short, Kerberos was the example. Kerberos, the security layer in Hadoop, was put there so that Yahoo could be compliant with some of the SEC regulations that they were facing. So, and then on top of that, there's some very important data management systems. At the end of the day, because this talk is about data scientists, I don't think you want to burden the data scientists with this issue. What you want to do is provide the data scientists with a mechanism so that they can only see the data that they're supposed to see. And of course, there's this balancing act with data scientists and being able to self-serve, right? So they should be able to go get the data that they need and only the data that they need to get their jobs.
So let me kind of put this question a bit for a
Yeah.
second. So, coming from IT, right? I
Yeah.
understand that encryption and everything is computationally expensive.
Yeah.
It's a hassle. And so if there was any feedback I had to take back to senior strategic management from your perspective, does security even make sense? I mean,
It totally makes sense. It's just every layer of security is going to cost more, right? And it's not a huge tax, but every layer of security is going to cost you a bit more to implement. And so what you want to do is you want to have kind of the menu of different levels of security that you can have, and then so we kind of have that menu, and I keep emphasizing with the team, Our job is not to force a security model on our customers or a compliance model. Our job is to help them articulate what is their security policy and what are the policies do they need to adhere to and to help them implement to those. Anyway, this is a whole nother talk in and of itself, so thanks for the question. And it's, you know, I know a lot of us, especially data scientists, our eyes glaze over when we start talking about this, but I can tell you, for us to keep experiencing the growth in this industry that we all want to see, this compliance stuff, we just have to nail it and do it well. Which is why we've got all that compliance stuff. This is more of a marketing slide that I chose to put up because of your question, but that's why we've got all these logos. Yeah.
Do we have any performance data about how H2O can scale up in the Spark?
Performance data about how H2O scales up in Spark. No. So we were pretty impressed with H2O just by observing one of our customers working with them. So we work with H2O to get it running on our cluster, same as we do with Spark. We get it running on our cluster and then turn it over to our customers. What I can say, the performance that we focus on a lot at Altiscale is time to business value, as opposed to time to get a job done. That's all important, but time to business value. So what we observed with H2O and the customer that was using it on our cluster is they kind of roll through dev, prod, test into production pretty quickly with H2O. And we're getting some pretty good modeling results out of it fairly quickly. And okay, put it this way. I can't give away too much information, but essentially, is this recorded? All right. They had a technology that was proprietary to our customer that was pretty cool, but then they replaced, and I won't say what it is, but they replaced it with H2O and rolled the whole thing out pretty quickly. So a lot of this isn't about how fast does any particular job get done, although there were good comparisons there. It's, hey, how fast does it take from the time that you want to try out the system until you actually get it in production and it's generating revenue for you or some sort of value for your customers. But they're, like I say, we're not religious about any particular tool. We see a lot of people kicking the tires on Spark these days, but only a small percent of those folks are rolling through into production. That's happening more and more, but it's kind of a slow transition.
I mean, when there's that friction, when people aren't actually going to Spark, what are they going to?
When they're not going to Spark, so we see more customers going into production right now with Impala than with Spark, and I know that Impala can be difficult to run, but we kind of take that. We Altiscale take that pain on behalf of our customers. So then, as long as they understand their own data set well and the kind of queries they can and can't do, then those interactive queries can go pretty quick.
So if I understand correctly, an Altiscale is basically built like an abstraction layer on top of Impala that makes it easier to use.
So the question is, have we built an abstraction layer on top of Impala that makes it easy to use? So when you think of that from a programming perspective, I'd say that SQL, go figure, is the abstraction that makes Impala easy to use. What I would say is that it's really hard to get all of these systems and tools to work together. So our special sauce is good people and tools to make sure all of that happens, and good monitoring to make sure that when it stops working, we fix it even before our customers notice in most cases. So by taking care of all of that hard stuff, then it's kind of an abstraction in the sense that the systems you're supposed to be able to use, you can actually use in the way that their manuals say they should be used, as opposed to having to root around and finding slow nodes or failed nodes and cycling through different operating systems and all of that stuff that people shouldn't have to worry about. All right, thanks so much for listening. Thanks for listening.